Alright guys, welcome back. We're going to be solving question 13 from Fundamentals of Electric Circuits. And in this one, we know that the charge entering a positive terminal of an element is this equation that we have for the charge. And also we have the voltage across the element plus to minus. With this formula, the first part of the question is asking us to find the power delivered to the element at 0.3 seconds, and also in the B part, we need to calculate the energy delivered to the element between 0 to zero point 0.6 seconds. So first of all, we need to know the relationship between the power, charge, current, and the voltage. And we solved a couple of questions in the previous videos that we know that our current, or I, is equal to derivative of charge over time. And also the power would be derivative of energy over time, which if you just multiply this by dq over dq, we can write this down as derivative of energy with respect to charge times derivative of charge with respect to time. And we know this is going to give us the voltage, and this is going to be our current. So we're going to get to that famous formula of P is equal to VI, and that's what we need. In the A part of the question, we basically need to find the power delivered to element at 0.3 seconds. So first of all, we need to find the Q in here. We need to find the current in here. So our current would be derivative of the first equation with respect to t. So let's just find our I first. So the I would be derivative of our charge. So we have 5 sine of 4 pi t. So derivative would be 5 times 4 pi, and sine would be cosine of 4 pi t. And since the charge is in millicoulomb, this is going to be in milliamp too. We already have the voltage, so we don't need to do anything about that. So we just have to multiply these two values. So we're going to have, for our V, or voltage, we're going to have 20 pi cosine of 4 pi, and the time that we have in here would be 0.3 seconds. So we're just going to put 0.3 in here. That's going to be our voltage, and our current would be that's going to be our current, and our voltage would be 3 cosine of 4 pi, again in 0.3 seconds. So the rest of this is just a calculation. One thing that you need to keep in mind is that the values that we have for cosine and sine in here, they're actually both cosine. So we just have to put this as a radian. So first of all, make sure that your calculator is set to radian instead of degree, because you're going to get wrong answers. I'm just going to click on this. So now it's on radian. So we're going to have 20 pi cosine of 4 pi times 0.3, and that's going to be multiplied by 3 cosine of 4 pi times 0.3. And yeah, this is going to give us 123.37. Let's just double check the units one more time. So our current, our voltage, we figured that is, actually this is our Y and this is our voltage. So these two are switched. So our current, as we talk about, is, so that's for the A part of the question. And the B part, we need to find the energy delivered to the element. So we are looking for the W. So which means if we just cross multiply in here, we're going to get our dW is equal to P dt. So we just need to do the integral on each side. On the left side, we're going to get the W, and we have a definite integral from 0 to 0.6. So 0 to 0.6. And the P that we're going to have is basically the multiplication of these two. We just have to put T instead of 0.3. So it's going to be 60 pi, 20 pi times 3. And we're going to have cosine squared of 4 pi t, because we have two cosines. This is going to be our dt. The rest of this is just finding this integral, and what we need to figure out in here is that we know that cosine squared of x is equal to 1 plus cosine squared of 2x divided by 2, and that's how we're going to solve this integral. So 0 to 0.6, 60 pi. I'm just going to factor the 1/2 outside of the parentheses, so 1 plus cosine of 2 times 4 pi t. So this is going to be pretty easy, 3 pi, and we're going to have t plus 1 over 8 pi sine of 8 pi t, and you can see if we just do the derivative of this sign, we're going to get what we have in here. And now we just have to plug in everything. And this was from 0 to 0.6. So 0 is going to make everything 0. So we just have to find a 0.6 sine of 8 pi times 0.6 divided by 8 pi. And let's see what we get. So basically 3 pi times 0.6 plus sine of 4.8 pi. Again, make sure that your calculator is set to radian, 8 pi. And yeah, that's going to be the final answer, 58.75. And if you just want to double check all the units that we have in here, so we had the power based on milliwatt, time is in seconds, so that's going to give us the energy in millijoule. So yeah, I hope everything was clear. Let me know if you guys have any questions. You guys take care. See you in the next video. Have a good one.